Your fastmcp server needs more than just code. It needs a repeatable way to define its entire runtime environment, from dependencies to deployment settings. We'll build a complete fastmcp.json configuration that goes beyond basic package lists, showing how to declare your server's entry point, Python environment, transport method, and even log levels, all in a single file that replaces manual setup scripts. You'll see how this schema-backed configuration enables IDE auto-completion, version-specific validation, and seamless migration from CLI arguments to declarative JSON.
Schema https://gofastmc.com/public/schemas/fastmcp json/v1 json. Source path server pi. Entrypoint MCP. Environment dependencies pandas requests.
This demonstrates the declarative infrastructure pattern, where server configuration, dependencies, and deployment parameters are defined in a version JSON manifest, rather than through imperative scripts or CLI arguments. The configuration acts as a single source of truth that replaces traditional setup scripts, environment variables, and manual dependency management with a structured, IDE-supported format. What distinguishes this approach is its ability to handle the entire server lifecycle, from dependency resolution to transport configuration, while remaining environment-agnostic and tool-readable. The pattern works by defining 3 core sections: source, required for code location and entry point; environment, optional for dependency management and runtime specifications; and deployment, optional for transport settings and operational parameters. The schema reference enables validation and IDE auto-completion, while optional fields like environment type, defaulting to UV, and source type, defaulting to file system, provide sensible defaults. Dependencies can be specified directly in the JSON, via requirements files, or through editable installs. And the configuration supports environment variables and Python version pinning, all while maintaining compatibility with both local development and production deployments. This approach matters because it eliminates the fragility of implicit environment setups and shell-based workflows, replacing them with a portable, version-controllable configuration that works across different fastmcp clients and transports. The trade-off is initial setup complexity, but the benefits include reproducible deployments, IDE integration, and the ability to migrate seamlessly between CLI arguments and JSON configuration as projects scale. It's particularly valuable for AI tooling, where servers must integrate with multiple clients, like Gemini CLI, while maintaining consistent behavior across different Python environments and dependency sets. Let's break it down line by line. This defines a fastmcp configuration object in JSON format, using the V1 schema for validation and IDE support. The only required field is source, which specifies the server entry point, while environment, defaulting to UV package manager, and deployment sections handle dependencies, runtime settings, and transport configuration. Optional fields like source type, defaults to file system, and dependency specifications support both direct package lists and requirements files, enabling environment-specific configurations while replacing manual dependency management.
Schema https://gofastmc.com/public/schemas/fastmcp json/v1 json.
Declares fastmcp's V1 JSON schema for IDE validation and runtime checks, enables autocomplete in modern editors, and prevents invalid configurations by validating against the official specification. The schema field points to a versioned schema URL, ensuring compatibility while allowing updates. fastmcp supports both version-specific V1, JSON, and latest schema references for controlled migrations.
Source.
The source key declares your fastmcp tool's executable location and entry point. It specifies the Python file via path and the main function via entrypoint, with an optional type field that defaults to file system. This mandatory section replaces CLI arguments, enabling configuration as code with IDE autocomplete support when paired with the schema validator.
Path server pi.
Defines the server module location in fastmcp's configuration as code system. This path, combined with the optional source type, defaulting to file system, directs the runtime to your @mcp tool implementations while supporting alternative sources like Git repos. The complete configuration typically includes deployment settings, transport, log level, and environment specs, defaulting to UV Package Manager, though only the source field is strictly required for basic operation.
Entrypoint MCP.
Specifies the entry point function name that fastmcp will execute when handling requests. This follows the standard pattern where fastmcp looks for a function with this exact name in the specified source file, treating it as the root request handler. Required field that defines your service's execution starting point. This closing brace completes the environment block in fastmcp's JSON configuration, which follows the v1 schema defined in the schema field. The configuration uses implicit defaults. Source type defaults to file system, and environment type defaults to UV, though only the source field is strictly required. While this example shows just source and environment, production configs typically include a deployment section for transport settings, log levels, and other runtime parameters.
Environment.
The environment key declares runtime dependencies and execution parameters. It specifies Python packages required by the server while defaulting to UV for package management, with optional overrides for Python version or requirements files. This configuration as code approach replaces manual dependency management, enabling consistent deployments across environments while supporting IDE validation through the JSON schema.
Dependencies, pandas, requests.
This declares Python package dependencies in fastmcp's configuration as code system. The environment manager installs these packages automatically using UV by default, replacing manual dependency management. You can also specify a requirements, TXT file, or split dependencies across environment-specific configs. This closing brace terminates the fastmcp JSON configuration object, which follows the v1 schema for tool deployment. The schema URL at the top enables IDE validation and autocomplete while supporting both version-specific and latest schema references. The configuration uses the standard three-section pattern. Source, required, defaults to file system type. Environment, defaults to UV Package Manager, and optional deployment for runtime settings like transport and logging. This declarative approach replaces CLI arguments and shell scripts, supporting requirements files, environment variables, and multi-file splits for dev/prod environments. Only the source field is strictly required, making it backward compatible with existing setups. This closing brace completes the fastmcp JSON configuration, which defines server deployment, dependencies, and runtime behavior. The schema reference enables IDE validation and autocomplete, while the optional source type defaults to file system and environment type defaults to UV. Fields follow fastmcp's convention over configuration approach. Only the source block is strictly required, but production configs typically include deployment, transport, log level, and may split environments, dev/prod across files, replacing legacy CLI arguments and shell scripts. fastmcp configuration pattern. The fastmcp.json schema transforms CLI complexity into structured WHERE what-how sections, source location, environment dependencies, and deployment runtime, while requiring only the source field as mandatory. Modern IDEs leverage the schema reference for autocomplete and validation, but omitting it sacrifices both IDE support and version control through schema URLs, v1v's latest. Environment configurations can pull dependencies from requirements files or inline lists, while deployment settings handle transport protocols, logging, and environment variables, all through optional but powerful JSON sections.
The configuration file that declares nothing but location becomes the silent orchestrator of entire environments.